in this video we are going to look at how we go about using one-sided limits. Right? So if f is a function and c and l are real numbers, the limit of f of x as x approaches c is equal to L if and only if the right-hand limit and the left-hand limit are the same, and if they're the same value, that value L. So this gives us a way for us to have a limit. So when we found limits previously and we said that the limit exists, really what we were doing is we were looking at what is true from both sides of that graph. So we approach from both the left and right. Now we can formalize that a little bit more and say the right-hand limit needs to be equal to the left-hand limit. And then you could use this to rephrase what it means to be continuous. So a function is continuous at c if and only if the left-hand and right-hand limits are equal and the thing that they equal is the function value at c itself. With those things in mind, with these ideas of left and right-hand limits, we can now formally look at the idea of continuity on a closed interval. We've talked about continuity on an open interval, but now we can talk about it on a closed interval. So a function is continuous on a closed interval, AB, when three things are true. Right? So it needs to be continuous on the open interval. It needs to have the right-hand limit as x approaches a needs to be equal to f of a, and the left-hand limit as x approaches b needs to be equal to f of b. Right? So the function is continuous from the right at a, and it's continuous from the left at b. The idea there is we can have a graph, if this is A and this is B. In the middle, you need to have continuity in the open interval from A to B. But as we approach A from the right-hand side, so as we're getting closer and closer to A, but we're moving towards A from the right, so we're moving along that direction, then we need to approach the function value at A itself. So if our function A was defined way up here instead of that first dot that I drew, then it would not be continuous on the closed interval. But as long as it's continuous there, we're good. And as we approach B from the left, right, so we're getting closer and closer to B from the left-hand side, as long as that's equal to the function value, we would have that continuity on that closed interval. Some properties of continuity: if B is a real number and f and g are continuous at x equals c, then the functions below are also continuous at c. So a scalar multiple of a function f is continuous wherever f is continuous. Sums and differences of f and g are continuous wherever f and g are continuous. Products are continuous wherever f and g are continuous. Quotients are continuous wherever f and g are continuous, provided that when we plug in that value c, it's not going to give us 0 in the denominator. If g is continuous at c and f is continuous at c, then the composite function given by this is also continuous at c. So those are the ideas of continuity. In our next video, we're going to close this section by talking about the intermediate value theorem. We will see you there.